Alright, hello and welcome. This is going to be our homework help video for the homework 19 solving systems of equations quest review. I will post more information on my calendar about how that quest is going to work, but for right now let's just treat this like a homework and get some good practice solving systems of equations by various methods. Alright, so for 1 through 6, let's solve with elimination. All right, elimination is a good choice for problem number 1 here because I can see I already have a 0 pair. This 4y and this negative 4y, when I add those together, they are 0y. They cancel each other out because they form a 0 pair. They're exact opposites. So I can just put a plus down in front, a line underneath, and these will cancel right out. Now let's see what else is going to happen in this equation. The x plus the negative 2x is just going to become a negative x. The 0 plus the 8 is just an 8. Equal sign stays in the middle. This is almost solved. I just need to divide both sides by a negative 1. Get x equals negative 8. Forget my negative. Plug that back in either spot, but I like that spot right there. So I'm going to copy down that top equation. X plus 4y is now going to become negative 8 plus 4y equals 0. Add 8 to both sides. I get 4y equals 8. Divide by 4, divide by 4. And I get y equals 2. Alright, put this together in an x comma y and I get negative 8 comma 2. Alright. Let's do maybe something like problem, number 4. See what happens here. Well, let me just say, just looking at problem number 3, this is the same equation twice. So this has infinite solutions. If you have the same equation twice, it is just automatically infinite solutions. All right, let's look at 4 though. So I don't have a 0 pair, but I can multiply the bottom equation by negative 1. And that way I can get a 0 pair with both my x's and my y's. Because the 0 pair of 2 is a negative 2. So that I convert this 2 into a negative 2, well, I multiply it by negative 1. And the same thing's actually going to happen with the y's. So we're going to see what happens here. Everything flips its sign. Top equation stays the same. I'm going to add these together. And this time, because I have two 0 pairs, these cancel out, these cancel out, these cancel out, these cancel out. I'm left with 0 equals negative 8. This is a false statement, so this one has no solutions. All right. So if I had gone through the process of solving this, I would have gotten 0 equals 0, which is a true statement. And that's how we could have told algebraically that this has infinite solutions. This one leads to a false statement, so no solutions. All right. 5 and 6, these are kind of our harder ones where I don't have a 0 pair, I don't even have multiples. Gotta get a little bit more creative here to form a 0 pair. So I'm going to try to form a 0 pair with the x's here. That means I'm going to multiply the top by a positive 9, so that'll get 90x. And the bottom by a negative 10, so I'll get negative 90x, and now I'll have a 0 pair. So when I multiply by 9, I get 90x plus 63y equals, let's say it's negative 135, but I'll double check. 15 times 9, negative 135. Multiplying everything by negative 10 here, so negative 90x minus 90y equals 0 times anything is still just 0. I'm now ready to add these together. And I get 53y. No, that's not 53. What is that? So 63 minus 90 is negative 27. I don't know where I get that from. negative 27y equals negative 135. Divide both sides by negative 27. I'm hoping this goes in evenly. And it does. I get y equals 5. I'm not done. I've got to come back and plug this into either equation for y. I'll just pick that bottom one. 9x plus 9y, but y gets replaced with a 5 now, equals 0. 9x plus 45 equals 0. Subtract the 45 from both sides. 9x equals negative 45, divide by 9, divide by 9. X equals negative 5. Put it together into an ordered pair. I get negative 5 comma 5. Alright, double check with the top equation. Let's see, negative 50 plus 35 equals negative 15. Yep, that checks out. Alright, solve by substitution. Well, okay, we've got some interesting ones here where one of our equations is already solved. Y equals 0, that just tells us one of the answers. So now I can take that 0 and plug it in for this y right here and get the equation 0 equals x plus 2, minus 2 from both sides, negative 2 equals x, and I'm already done. I can just write this as an ordered pair, negative 2 comma 0. Same thing here. Plug that negative 5 in for this y here and solve for x, and you'll be done. All right, problem number 9, we see that this y in the second equation is already isolated, so I want to put a box around the other side and draw an arrow to the y in the top equation. Now let's rewrite that top equation. 4x minus 5y, but y has been replaced with an 8x minus 20. Keep this out of parentheses so we know to distribute. Equals negative 8. Now our only type of variable is an x, meaning we can solve for it. I'm going to distribute that negative 5. I'll get 4x minus 40x plus 100 equals negative 8. Negative 36x plus 100 equals negative 8. Minus 100 minus 100. Negative 36x equals negative 108. Let's double check that that divides in evenly. 108 divided by 36 is exactly 3, so we get x equals 3. Plug that back in. I'm going to use the bottom equation. Y equals 8 times 3 minus 20. Y equals 24 minus 20. Y equals 4. Put it together into an ordered pair. 3 comma 4. Alright, double check with the top equation. Let's see, 12 minus 20 equals negative 8. Negative 8 equals negative 8. Yep. Alright, now what do we do with a problem like number 11 or 12? We haven't seen this before. We want to use substitution, but no variable is isolated. Can we still do it? The answer is yes. We just have to isolate a variable on our own. So I'm going to copy down that top equation in number 11 here. Negative x minus 3y equals negative 17. All right, and I'm going to try to isolate this x here. So I'm going to add 3y to both sides. Negative x equals 3y minus 17. I'm going to divide everything by negative 1. And I get x equals negative 3y plus 17. Now I do have a variable isolated. I have to keep track. This came from that top equation, so I've got to plug it into the bottom equation. I'll plug it in right there for x. Now I'll get negative 7 times negative 3y plus 17 minus 6y equals negative 14. So this is our second equation, but the x has been replaced by this expression here. Now let's solve for y. Distribute in the 7, we'll get 21y. 7 times 17, negative 119 minus 6y equals negative 14. Add 119 to both sides. Maybe we'll combine some like terms while we're at it. We get 15y equals 105. Divide by 15, divide by 15. We get y equals 7. Okay, plug that into either equation. I'll plug it into the top one. Negative x minus 3 times 7 equals negative 17. Negative x minus 21, whatever, an 8. It's negative 17, add 21 both sides. Negative x equals 4. Divide by negative 1, divide by negative 1. X equals negative 4, write it as an ordered pair. Negative 4 comma 7. Let's see if that works with the bottom equation. Let's see, that'd be 28 minus 42 equals negative 14. 28 minus 42 equals negative 14. Checks out. All right, for the last problems, we need to pick a method, either substitution or elimination, to solve and then explain why we picked that method. So for 13, I'm going to pick elimination because we already have a zero pair. All right, now for number 14, you could actually go with either as long as you defend it. Maybe you want to do substitution. Because the x in the top equation is easy to isolate. All right, and I'll solve one more. I'll solve 16 here since it's got the fractions. I'm going to use elimination. Because I can get a zero pair with x. All right, so how am I going to do that? Well, the zero pair of a negative 8x is a positive 8x. So I'm going to take everything in the top equation, I'm going to multiply it by a positive 8, so that I get an 8x. Let's see, negative 5 times 8 is negative 40, divided by 4 is negative 10, so negative 10y equals 1/4 of 8 is a 2. All right, unfortunately, like terms are not conveniently lined up here, so we're going to get some extra terms. But the x's will cancel out. These can't be combined, so I have to write it as negative 10y minus 18 equals negative 6y plus 2. But now y is my only variable and I can solve for it. I'm going to move my variables together. I'll move the smaller one by adding 10y to both sides. Negative 18 equals 4y plus 2. I'm going to subtract 2 from both sides. Negative 20 equals 4y, divide both sides by 4. Negative 5 equals y. I'll plug that back in right there. Okay, negative 8x minus 18 equals negative 6 times negative 5. Negative 8x minus 18 equals 30. Add that 18, negative 8x equals 48, divide by negative 8, get x equals negative 6. And write it as an ordered pair, -6, -5. Double check with the bottom equation, or top equation actually, since we use the bottom equation to solve. -6 plus or minus 20, so it would actually be plus 25 fourths. 4 goes in 6 times, so -6 minus 6 and a fourth becomes -6 plus 6 and a fourth. The 6's cancel out, I'm left with 1/4. I'm pretty sure that double checked. I probably should have written it down instead of trying to do it in my head, but we'll assume I got it right. Actually, I think I got the answer key. Let's see if I got it right. 16, -6, -5, yeah. All right, well, good luck finishing the rest of this up, and have a good rest of your day.